1324, presented by Ms. Yvette Chuca, Mr. Ruben Carizales, and Mr. Albert Isasi. Our session will be starting soon. This session will be recorded so that you can come back later to it if you need to, and so that others who have missed out on today's events will be able to come and watch it. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with the information we will be sharing today. We'll be sending the 1324 room link on the chat so that you can connect to your session if you are here for Math 1324. Without further ado, I will pass it on to our presenters so that we can begin. Thank you.
Hello, everyone. Thank you for joining us today for another session of Friday Happy Math Hour. And if you're in 1324, they put the link there for you to go to the other room. And for 1314, we're going to be discussing inverses of matrices and determinants of matrices. And so these are the last two topics of the 1314 course objectives. And so for most of you, you are covering this two topics this week, and then probably starting to review. Next week will be exams and reviews for your last exam and your final. But let's go ahead and get started. At any time, if you have any questions, please let me know, and I will address them as we go on. So first, we want to talk about what is an inverse. And an inverse can occur only if you have a square matrix. And a square matrix, what that means is that it has the same number of rows and the same number of columns. And so here's an example of a 2x2 matrix. And the identity matrix is a matrix that has all ones in the diagonal, and the rest are going to be zeros. So for the 3x3 identity matrix, notice that it has all ones in the diagonal, and everything else is going to be zeros. So in order for a matrix to have an inverse, if you take that matrix and then you take multiply it times its inverse, it's always going to give you back this identity here, or it could be this one, or it could be another identity matrix, a bigger one. Okay, but the important thing here is if you multiply A times A inverse, and it gives you the identity matrix, then that's going to be one way to determine if they are inverses of each other. But not only do we multiply A times A inverse, you should also be able to multiply A inverse times A. So you should be able to reverse them, and it should still be able to give you the identity matrix. If that occurs, then we say that the two matrices are going to be inverses. And the inverse, the symbol we use is this subscript of a -1. So we read this as A inverse. Okay, so let me go to the next slide. So here we have two matrices. We have matrix B and matrix A, and we want to show that B is the inverse of A. Okay, so first what we're going to do is we're going to multiply A times B, and then we're going to multiply B times A. And if it gives us I, remember that I is the identity matrix that has all ones in the diagonal. Everything else is a zero. If that happens, then we can say that they are inverses of each other. Okay, so here's the first A times B. So remember from last week, if we want to multiply two matrices, they have to be the same order, which they are. Not the same order, but it has to have the same number of columns and then the same numbers of rows for the second one. So here's we would take the first row by the first column. And so I'm going to multiply -1 times 1 is -1, and 2 times 1 is 2. And then we're going to go ahead and go to the next column, which is -1 times -2 is +2. And 2 times -1 is -2. And then we don't have no more columns, so we go to the next row. So -1 times 1 is -1, and 1 times 1 is 1. Then we go to the next column. -1 times -2 is a +2, and 1 times -1 is a -1. So we'll simplify these numbers. -1 plus 2 is going to be 1. and 2 minus 2 is 0, negative 1 plus 1 is 0, and 2 minus 1 is 1. So notice here that I get the identity matrix. So that is good, but if we want to show that they are inverses, if we reverse them as b times a, it should also give us the identity, which it does. And now we can say that since a times b and b times a both gave us the identity matrix, then we can say that these two matrices are inverses of each other. Okay, so that is the way that we would check if something is an inverse of the other. So one of our goals is going to be finding the inverse, because we want to use the inverse to help us solve a system. So remember, in chapter 7, you learn different methods of solving systems. You learn how to solve a system by graphing, by addition, by substitution. And then we started with the matrices, and last week you learned how to solve a system using row operations with matrices. And so today with the inverse, you can also use the inverse to solve a system. And so there's 3 ways to do this. The one that most people prefer is going to be using this formula here on the top right. But then you do have 2 other options. So for a 2 by 2 matrix, I'm going to go ahead and use, I'm going to show you all 3. And then first, anything bigger, we can use the calculator. These methods would work for anything bigger as well. But notice here that that the formula is only good for a 2 by 2 square matrix. Okay, so let's try the first method. So this method is, we're going to take the matrix A times the variable matrix, and then it's going to be equal to the identity. So it says find the inverse of A. Okay, so the first thing we're going to do is we're going to set it up. We're going to set up this equation. Okay, so here's my A, right? That's my matrix A. And then for the matrix X, we're just going to use X 1, 1. Remember that the 1, 1 represents first row, first column. This one represents first row, second column, second row, first column, and so on. And then we say that it's equal to the identity matrix. Okay, so then we are going to actually multiply them together. So I'm going to take this row and multiply it times this column. So I get 1 times x11 is going to be x11, and 4 times x21 gives me a 4x21, and then 1 times x112 is x112, and then 4 times x22, that's 4x22. So these numbers in here, I'm getting them just by multiplication. And so the next one would be negative 1 times x11, that would be this one here, and negative 3 times x21, which would be here. And then this times the next column, and this number times this number here. And so we end up with this here, okay? And all we know is that this is equal to our identity matrix. And so what we're going to do is set up a system. And the reason that we set up a system is, since you worked with systems in chapter 7, some of you might be more comfortable working with a system. Okay, so here are my systems. We're going to take x11 plus 4x21, and we're going to set it equal to 1. So that's going to be one equation. And then negative x11 minus 3x21, set it equal to 0. That's my second equation. And then I'm going to do the same for the second column, x12 plus 4x2 equal to 0, and negative x12 minus 3x2 is equal to 1. So here I have 2 systems. And again, it looks weird because of the x11 and the x21, but you can just treat them like if there was a number. So in this system here, notice that this is a positive and this is a negative. So if I add them together, I can solve for the variables. Okay, so I can add the equations, so these would cancel out. And then I have 4 plus negative 3 is going to be a 1, x21. And then 1 plus 0 is 1. So now I know what this number is. And then I'll do the same for, now I'm going to take this answer and back substitute. Okay. So I'm going to use the first equation, x11 plus 4, x21. I already know that x21 is 1, so I just substitute it here. And then 4 times 1 is 4, and I'm going to subtract 4, so I get negative 4 plus 1 is negative 3. So that gives me what x11 is. And now I'm going to do the same thing for the right side. So I can add these two together, and this would cancel. And then 4x to 2 minus 3x to 2 gives me a positive x to 2, and 0 plus 1 is 1. We're going to back substitute. So I have x12 plus 4 times 1 is equal to 0. Subtract 4 on both sides, and I end up with negative 4. So far what I have is x21 is 1, x11 is negative 3, x22 is 1, and x12 is negative 4. So I can take these and place it into a matrix, okay? So x111 is my first row, first column, and so the matrix is going to look like this, right? Negative 3, and then we have a 1, 2, that's the first row, second column, so we have negative 4, and then we have our 1 and our 1. So this is going to be our inverse. So if you feel comfortable with systems, then this might be the method that you're going to feel more comfortable with. But the second way to do it is using row operations, what we used last week. And in order to do the row operations, we're going to have our matrix A, and then we're going to attach the identity matrix. Okay, so it will look something like this. So here's my matrix A, and here's my identity matrix. And then we're going to use row operations, and what we want to happen is that on the left side, we want to end up with the identity matrix, and then whatever's on the right, that's going to be your inverse. Okay, so remember that the identity matrix is 1 0 0 1. So we want to have a 1 in this location, which we already do. So that makes it easy because we already have our 1 here. So now we're going to make whatever's below it a 0. Okay, and in order to make this a 0, I'm going to add 1 plus negative 1. So that is what I'm saying here, row 1 plus row 2, and then whatever we get, we're going to place it in row 2. So we're not going to change row 1. So I just wrote row 1 here. Okay, and now I'm going to add, so 1 plus negative 1 is 0. 4 plus negative 3 is a 1. 1 plus 0 is 1. And 0 plus 1 is 1. So we have our 1, we have our 0, so that's great. But now we have our 1, we want to have a 1 here, which we do. So that's also great because it's less work since we already have the 1. But I need to make this 4 a 0. Okay, so if this one was a negative 4 and I add it to the 4, then it would be 0. So what we're going to do is multiply negative 4 times the row 2, and then we're going to add it to row 1. And whatever answer we get, we want to place it back in row 1. So we're not going to change row 2. So we're just going to write down row 2. It didn't change, as you can see here. And now I can say negative 4 times 0 is 0, plus 1 is 1. So I write my 1 here. Negative 4 times 1 is negative 4, plus 4 is 0. So I write my 0 here. And negative 4 times 1 is negative 4, plus 1 is a negative 3. And negative 4 times 1 is negative 4, plus 0 is negative 4. So now we have our identity matrix on the left side, and we have this information on the right. So this information on the right is what is going to be called our inverse. So we can just write A inverse is equal to negative 3, negative 4, 1, and 1. Okay, so that's going to be your second method. So our third method, which I think most people find it to be easier, is going to be using a formula. So here in the formula, you're given a matrix, and notice that the elements are A, B, C. And so the inverse, we're going to say 1 divided by, we're going to multiply A times D and then subtract it from B times C. So A times D minus B times C. And then inside of the matrix, we're going to switch A and D. So notice now I have D up here, and then I have A. For B and C, we're going to switch the sign. So if this is positive, then we're going to make it negative. And the same for this, it's positive, we make it negative. Okay, so let's see how it works. So it's before I move on, this bottom part is called a determinant, and that's what we're going to talk about for a section 8.4, the next part of this presentation. Now, if you get a 0 down here, you cannot divide by 0. So what that means is that you would have no inverse. Okay. So let's try the example. So here we have A is our matrix. If it helps, you can label these. You don't have to, but if it helps, you can. And so I'm going to have the formula. I always like to write it next to my problem. And now I'm going to substitute these variables. So I have A inverse is equal to 1 divided by A. A is 1. D is -3. And then B is 4. And C is -1. So now inside the matrix, notice that I switched the 1 and the -3. So these were switched. Now my 4 is positive, so I'm going to make it negative. My -1 is negative, so I'm going to make it positive. Okay. And now we just simplify. So 1 times -3 is -3. -4 times -1 is +4. And -3 plus 4 is going to be a 1. And 1 times the matrix is going to be itself. And so you can see this is the answer that we got for the first 3 methods. Okay. Any questions on those methods? So again, as I mentioned before, these methods are you're going to be able to see all 3, and then you can use whichever one you feel more comfortable with. So let's use, it says any method, so let me see which ones I used. So we're going to use the formula. So the formula is going to be this right here again. And then let's go ahead and use the first one here. So we have A is 3, D is 2, and then we have B is -1 and C is -2. We're going to switch the 3 and the 2, which is what I did here. And then my sign, I need to change this to a positive and this to a positive. And now we're going to simplify. So 3 times 2 is 6, and -1 times -2 is going to be a -2. 6 minus 2 is 4, so we get 1/4 times the matrix. 1/4 is your scalar, so we can multiply everything by 1/4. So we're going to have 1/4 times 2 is 2/4, but if we reduce, then we get a half. 1/4 times 1 is 1/4. 1/4 times 2 is 2/4, which is 1/2. And 1/4 times 3 is 3/4. So this would be your answer. Okay, so let's look at the next one. If we substitute in the values, A is 3, D is 2, B is -1, and C is -6. So if we simplify, we have 3 times 2 is 6, -1 times -6 is +6, and 6 minus 6 is 0, but we cannot divide by 0, so we say that A is not invertible. So A does not have an inverse. Okay. Any questions on those two? Okay, so for the next one here, find the inverse of a 3 by 3. So usually if you have an inverse that's bigger than a 2 by 2, then technology would be helpful. But if you ran out of batteries all of a sudden and you needed to still, come up with an answer, then it does help to be able to do it by hand. Okay. Or I guess you could always run to the store and get batteries. But anyways, it's gonna be up to you, right? So so for this one, I show you the 2 ways here, but the first way, it seems very complicated, but it's not that it's complicated, but you have to keep track of all your information. And so I'm going to kind of just scroll through it, and then we can come back to it at the end of the session if you want to see it in detail. But basically, here's your matrix, and then you have your variable matrix. So these are just placeholders, right? And then you have your identity. And so what we do is we're going to multiply this row by the first column. So we would have 1 times x11 plus -1 times x21 and 0 times x31. And then you're going to multiply this row times this column, and then this row times this column. And then we go to the next row. So we would have this row times this column, this row times this column, and then this row times the third column, and then the last one would be this row times this column, and then keep going. Okay, so it's going to look something like this. Okay, and so after you multiply all of these rows with the columns, then you end up with these 6 things here, and what's set up to the matrix. So you can still get systems out. Okay, so here's my first system for my first column, so x1, 1, and so on. And then in blue is my system for my second column, and then the purple is going to be the last column. And so I set them all up like this, and now we can start solving the system. So you want to pick a variable that you can cancel out. So we'll start with the green one. Okay, so I want to get rid of this x1 once. So I'm going to pick the first equation and the second equation. And I'm going to multiply -1 to my first equation. So -1 times x11 is negative x11. Negative negative makes it a positive, and -1 times 1 makes it a negative. And then my second equation just stays the same. So the x11s will cancel, and then I'm left with x21 equals, or x21 plus negative x31 is equal to -1 plus 0. Okay, so now we continue. We're going to use the last equation, and then you're going to use one of the two here because we need to get rid of this x1 again. Okay, so it looks like I'm going to use the third equation and the first equation. So I multiply -6 to the first one, and I get -6x1. -6 times -x21, I get positive 6x21. And then -6 times 1 will give me a -6. If I add them, the x1's cancel. And then 6 plus -2 is a 4x21. And then I have my -3x31 is equal to -6. So now you have two new equations, right? And this is like in chapter 7, when we had 3 equations, you end up with 2, and then you break it down. So now you look at these 2 equations, and you want to cancel one of the variables. Okay, so let's cancel. I guess we're going to cancel the x21. Okay, so let me go back really quick. So these 2 equations I circled are going to be my new system, and then we're going to cancel the x21. So in order to cancel the x21, this should be a 4, so I multiply by -4. So I get -4x21. Negative and negative is positive, and then negative and -1 is +4. If I add it to the second equation, the x21s cancel, and I'm left with x31 is equal to -2. So now we take this answer and plug it in to one of the 2 equations so that we can get the next number. Okay, so I called it back substitute here. So then we end up with our x213, and then we back substitute again, and we end up with x11. So as you can see here, this process will give me my first column, and then you would do the same thing with, let me go back here. You would do the exact same thing, but with the blue and the purple. Okay, so as you can see, it's a long process, and so this method here might not be your best choice unless you really love to solve a system using that, and unless you like to use this method to solve systems. But either way, when you continue, this would end up being your solution. Okay, so don't worry if you felt that was too long. It's okay. Maybe you'll like the second method or the third method, but either way, and then I'm going to show you the calculator as well. Okay, so let me see on this, the second method. For the second method, you would attach the identity matrix. So here's all the ones, and then zeros in their diagonal. And then you would use the row operations to get this matrix here to look like IA inverse. Okay? And so you would use your row operations, and you would use this number to make everything below it 0. And so if you notice here, we got the zeros. And then you would keep using the method until we broke it down to your identity, and then your whatever's left on the right would be your inverse. Okay, so this is using the row operations. And then the last method is using the calculator. So I am going to show you how to do that. That way, in case you want to check your work, you can. And so let me just open it up really quick, and then I will share my screen. And last week, I did put a link to a video that I made on showing you how to use these calculators. Okay, so I can put that in there again today as well. So here we have -2, -3, and 1. So let me just put the numbers here first, and then I will share my screen. Okay, so -2, -3, and 1. -3 and 1. Oops. And actually, let me share the screen, and then maybe somebody can read them to me if I forget what they were. Well, let me put them in the chat so we can see them before I remove the screen. So -3 and 1, that's going to be our second row, and -2, -4, and 1 is going to be our third row. Let me share my screen really quick. Okay, so, and I'm gonna, so again, here you can adjust your rows by clicking on these numbers, right? So you can have more rows or less rows. Ours is a 3 by 3, and so the next number is -3, -3, and 1, and -3, 1, and then we have -2, -4, -4, and 1. Okay, so once you have your matrix, then you just press enter, and it's going to save it as A. So if you want the inverse, then you would press A, and then this is a symbol for inverse, and then you would press enter, and then it will give you your answer here. Okay, so that's basically how you would do it here. So again, the calculator, for anything that is bigger than 2 by 2, I would expect my students to, well, like if it was a 2 by 2, I would want my students to show me how to do it by hand if we were in the classroom. But if it's anything bigger, then I would let them use the technology. Okay, so let me go back to the PowerPoint, because the important thing is, well, why do we want these inverses, right? So let me go to where we left off. And I'm almost there. Okay, so we already did that. Okay, so the reason we want these inverses is to solve the system, okay? So in order to solve the system, you want to, this is going to be the way to do it. We're going to have X is equal to A inverse times B. X is the variable matrix, so that's like your X, Y, and Z, or your X and Y. And then, of course, A inverse is the inverse of the matrix. And then B is going to be your constant matrix, okay? So here it says use the inverse, this is the inverse, to solve the system. So they already gave you an inverse here. Okay? We don't have to find it. So here my solution is going to be, we need our matrix A, and that comes from the augmented matrix. So the number in front of X is 1, the number in front of Y is -3, and then we have our 3 and our -8. So this is going to be just the coefficients. And then B is going to be your constants, 4 and 12. And then X is your variables, X and Y. So here for the inverse, what they did, or what somebody could have done, is use any of the 3 methods, and they ended up with this inverse. Okay. So they want to know, tell us to solve the system. So we set up our equation. So we have x is x and y. We have our inverse, which they gave us, which is right here. And then we have our constants, 4 and 12. So all we have to do is multiply. So we're going to take negative 8 times 4 is negative 32. And 3 times 12 is 36. So negative 32 plus 36 is 4. And then we go to the next row. Negative 3 times 4 is negative 12, and 1 times 12 is 12. If I add these, I get 0. So from here, I can get my answer, which is going to be x is equal to 4 and y is equal to 0. And so that's going to be my system. That's how we would solve our system. But in the other one, they gave me the inverse. So here it says solve the system using inverses. They don't give you the inverse. So we're going to have to find the inverse. The first thing I would do is figure out what your matrix A is, what the matrix B is, and then go from there. So A are the coefficients 1, negative 5, 5 and negative 24. B is going to be my constants, 27, 128. And then X is my variables, X and Y. So for the inverse, I'm going to use the formula. So remember the formula was, let me write it here. So remember the formula to find the inverse was 1 over AD minus BC times AD minus B minus C. So I use this formula. That's what I have set up right here. Okay. So let's go see what we get. So A is 1. Here's my 1. D is negative 24. And then B is negative 5 and C is 5. So I plug in my numbers. I switch the A and the D. So now they're right here. And I switch the signs for negative 5 and 5. And if we simplify, then we have 1 times negative 24 is negative 24. Negative 5 times 5 is negative 25. Keep simplifying. So negative 24 minus a negative 25 is going to be 1. 1 divided by 1 is 1, and 1 times the matrix is itself. Okay, so that's our inverse. So that's the first part. Then we're going to take the inverse and substitute it into our formula here. So we have our x, our inverse, and our b. So now we need to multiply this so that we can get our answer. So we're going to multiply negative 24 times 27 and 5 times 128. Okay, so negative 24 times 27 and 5 times 128. And then we're going to have negative 5 times 27 and 1 times 128. So if we simplify, we end up with negative 648 plus 640 is negative 8. And negative 135 plus 128 is negative 7. So my solution for x is going to be negative 8, and for y is going to be negative 7. Okay. Any questions? Okay, so for this example, it says use the inverse matrix to solve the system. They already gave you the inverse, so we don't have to find it. And so again, we set it up with the equation. We need our a, so we get our a from the coefficients. 111, 354, 365, and then our constant 063, and then x, y, and z. Then we have our formula, x equals a inverse times b. So here's my inverse and then my b. So we're going to multiply. So again, you take the row with the column. So we say 1 times 0 is 0. 1 times 6 is 6. Negative 1 times 3 is 3. So 6 plus negative 3 is going to be a positive 3. And then negative 3 times 0 is 0. 2 times 6 is 12. And negative 1 times 3 is 3. So 12 minus 3 is 9. And then 3 times 0 is 0. Negative 3 times 6 is negative 18 plus a 6, negative 12. So my solution is x equals 3, x equals 3, y equals 9, and z equals negative 12. Okay, so the last section for this semester is section 8.4. and that's the determinant. So earlier in the inverse, I was showing you how to find in the formula 1 divided by AD minus BC. That AD minus BC is where the determinant's going to come from. Okay, so here you have a matrix. And so to find the determinant, you can either write it as DET with the parentheses A, or you can use this absolute value sign with the parentheses A. So if you see the absolute value sign, it's asking for the determinant. Okay, and then our matrix here, we also write the absolute value sign. So to find it, we're just gonna multiply A1 times B2 and then subtract A2 times B1. Okay, so we're multiplying these two numbers and these two numbers. So for example, let's do A. So here I want to find the determinant, so I can write it as the determinant of A. And then here's my matrix, right? So to find it, we're going to multiply 2 times 2 and negative 3 times 1. So 2 times 2 is 4. Negative 1 times negative 3 is positive 3. 4 plus 3 is 7. And so my answer is that the determinant of A is equal to 7. Okay, so my answer is 7. So then we can do B. So we just multiply 2 times 2 and 4 times 1. So 2 times 2 is 4. Negative 4 times 1 is 4. 4 minus 4 is 0. So the determinant of B is 0. And then the last one, 0 times 4 and 2 times 3 halves. 0 times 4 is 0. And negative 2 times 3 halves is going to be a minus 3. So we end up with negative 3. So that is how we find the determinant. In the calculator, let me just show you really quick. You should see the symbol there. And I'll still use A. So if you notice here the symbol DET, so you would press it, and then we would use A, and then we would press enter. And so it gives you the answer 1 in this case. Okay. So the symbol is DET. Okay, let's go back to the files. And let me just get the slide that we're in. Just give me a second really quick so I can scroll down. Okay, so let's see. Give me a second. I'm almost there. So here we go. Okay, so we did these already. Okay, so if you notice right now, the one that I used on the calculator was a 3x3 matrix. And so for the 3x3 matrix or anything bigger, it's going to be, you have to do an extra step. Okay, so if you have a square matrix, then we're going to be using the minor, and then we're going to use what we call a cofactor. And so in a little bit, I will explain this for you. It's actually not going to be as complicated as what it looks like. So these signs here, we're also going to use here in a second. So the way it works is it looks like this. So you have a 3x3 matrix, and you want to find the determinant. So the first thing we're going to do is we're going to find all the minors and the cofactors of A. And so the way it's done is that you pick the first row and the first column. So I'm going to start with 0, and I'm going to cross out this row and this column. And if you notice, it kind of leaves this little 2x2 here. So I'm going to call this -1, 2, 0, and 1. These are the numbers inside. Now, M11, that just means that I'm using the first number that's in the first row, first column. So I find the determinant here, -1 times 1, and 0 times 2 is -1. And then we're gonna do this for each number, right? So now I'm gonna go to the number 2. So I'm gonna cross the row and I'm gonna cross the column. And so I'm gonna get the 2 by 2 that's left over, which is 3, 4, 2, and 1. So I'm gonna multiply 3 times 1, 4 times 2, and I end up with -5. So the important thing here to remember too is this naming. I'm calling this M12 because it's the first row, second column. So then I go to the next one with the 1 here, right? So I'm gonna cross out the row and the column, and I have left the 3 and the -1, the 4 and the 0. So if I multiply, then I get the 4. And then we keep going to the next number. So you're doing this with each number. So we cross it out, and now I have these 2 and these 2 numbers, and I find the answer. So we keep going, and now I'm going on the second one. So what's left over? 0, 1, and 4, 1. So I multiply it out, I get -4. And then there's one more, right? And you keep going with the next row and so on. So essentially, at the end, you're going to be left with these 6 numbers, okay? So we're going to take these numbers, and we're going to be looking at the signs. So we're going to find what we call the cofactors of A, and we're going to use these signs here, okay? And so what happens is, if I take this number, -1, that's going to be my C11, C for cofactor, okay? And so if you notice, row 1, row column is a -1. And then we're going to take that, and then instead of M12, I'm just calling it C112. And if you notice here, we have a -5. And in the second column, we have a negative. So -5 times negative is going to be a +5. So the first one was a -1 times a positive number. That's why it stayed negative. So for the next one, C13, if you have a 4, is a +4 times a positive will remain positive. And then we go to the next one. 2 times a negative number will be a negative. And you keep going, do the same thing for the rest, right? And so you're left with all these numbers. And so now what we're going to do is the determinant is the sum of the entries in any row or column of multiplied the respective cofactors after you have multiplied. So to get the determinant, all you have to do is we would take the numbers here, and we're going to be multiplying. So here's my 0 times -1, and then I have 2 times my 5, and then I have 1 times the 4, because I'm using those in row 1 here. Okay? So if I multiply it, I get 0, 10, and 4. So 10 plus 4 is 14. But I could have used this second row if I wanted to. I could have said 3 times -2, -1 times -4, 2 times 8, and I'm still going to end up with 14. And if I use the last one, I'm still going to end up with 14. So your determinant is just going to be 14 for this problem. Okay, so the determinant of this matrix is going to be 14. So I wrote all 3. You don't have to write all 3. I just wrote them so that you can see that you get the same answer. So why do we even care about the determinant? The determinant is your 4th method, and this is from section 8.5. It's your 4th, like it's another method to solve a system. So here's your system. And so in order to use determinants, we use Cramer's rule. And that tells us that we're going to do the following. So you're going to have your coefficient matrix, which are just the coefficients, A1, B1, A2, B2. And then we're going to find the determinant of the entire matrix. So this is just where you multiply A1 times B2 and then B1 times B2. And then we're going to create a dx, the determinant of x here. And notice what happened here. My column for A, I removed it and I replaced it with my constants, okay, my constants. And then for dy, we removed the y and I replaced it with the constants. And then we find the determinants. And then to solve for x, we just divide dx divided by d and dy divided by d. Okay, so let me repeat that again. So the determinant of the whole matrix, and then instead for x, we're going to remove the x's and substitute it with the constants. And then for the y, we remove the y's and substitute with the constants. So for example, if I have this matrix, I would get my coefficient matrix, and I need all this information. So I'm going to write them here. So my coefficient matrix is 4, -2, 3, and -5. And then for D, I'm going to find the determinant. So it's 4 times -5 and -2 times 3, and it gives me -14. Then I'm going to find dx. So remember, we're going to remove the a's and get our constants. So our constants is 10, 11, and then we have -2 and -5. Okay, so 10 times -5 minus -2 times 11 gives me a -28. Okay, so give me a second really quick. Mom, ¿estás gritando? Estoy tratando de hacer esto. Okay, so we have the next one is going to be the dy. So notice I removed the y's and then I left the x's alone. So I replaced my y's with the constants. And then 4 times 11 and 10 times 3. So we get 14. So now that we have all that information, we have our x is equal to dx divided by d. So for dx, we ended up getting -28. And for d, we ended up getting -14. So if we put that in here and divide it, we get a 2. And then we get 14 divided by -14 is -1. And so we end up with our x equals 2 and y equals -11. I mean -1. So one of the things about chapter 8 is that it's new ways of solving the systems. And you might be thinking, well, I really loved the chapter 7 ones. They were pretty straightforward. And for some of us, we're gonna like the matrices more. But the matrices, normally, if you have a bigger system, then that's when they're gonna be more effective, or it's better to use matrices, especially if you have that technology at the end with bigger matrices. And so this is the last example we have from the section 8.5. And next week, most of you will be taking your exam 4 and then preparing for your final exam. So I believe we only have one more session, and in a little bit somebody will put it up, but I believe it's for a review for your final. But I'll wait to see if that's what's going to be happening next week. But anyways, if you have any questions, feel free to let me know. If you feel like you want some more time, then you can ask for a tutor, and we have some awesome tutors here. I'm waiting to see if anybody would like to join them for working out more math problems. And so I'm gonna send it over to Miss Salazar. I believe she's in here, and then she'll show us what's gonna be happening next week.
Alrighty, thank you, Ms. Chuka. Please join us next Friday at 3 p.m. for our Happy Math Hour, the final exam review for 1314 and 1324. Please know that our online tutoring is open now and available 7 days a week from 9 a.m. to 11 p.m., Monday through Sunday, and face-to-face tutoring is also available for Monday through Friday, 8 a.m. to 5 p.m. Thank you so much, Ms. Chuka, for presenting today. Thank you to the audience for coming and being a wonderful audience, and we hope to see you again next week. Have a great weekend. Thank you.